Hello, everyone. My name is Mr. Bryce with Susquehanna Valley High School here in Concord, New York. There's my email address. We're on Unit 7, Lesson 2. We're going to be reflecting parabolas. This is the Common Core Regents Algebra 2 non-Regents version. Common Core Algebra 2 non-Regents. That's the QR code. If you don't understand what I'm saying, the genius that made these worksheets can explain it to you himself. So what we're going to be doing is we're going to be reflecting functions across the x-axis and across the y-axis. Not x equals y. Okay. And their important mathematical process will be explored in this lesson specifically for parabolas, although the general ideas apply to all types of functions. The first exercise gets both of these important transformations. So let's look at the first one. There's another word for f of x. Do you know that other word for f of x? Why do you ask, Mr. Bryce? Yes, it is y. So here's the function f of x equals x squared minus 6x plus 5. Now, we're going to consider the function g of x, which is the negative of f of x. Determine a formula for g of x. Well, that seems pretty straightforward. What I do is I do exactly what it tells me to. I put a negative sign in front of f of x, x squared minus 6x plus 5. Now let's distribute that through. Negative x squared plus 6x plus 5. There is the formula. How is the graph of f of x transformed to produce the graph of g of x? This takes a little bit of thinking. I'm not going to use my graphing calculator to graph it on the grid over there. I am going to do the thinking about it. This part says I plug in a number, I get an answer here, then I take its negative. Remember, this stuff is the y value. So that's the y value. So what I'm going to do is I am going to take the y values and make them negative. It's as easy as that. So I take this y value and I take its opposite. 1, 2, 3, 4. 1, 2, 3, 4. So I just take their opposites. These two are the easiest because they're right on the x-axis. 1, 2, 3, 1, 2, 3. And those two. Now I'm going to neaten that up a little bit. It also works going the other way. Going down 1, going down 2, going down 3, going down 4, going down 5. This is 5. The opposite of 5 is negative 5. This is 5. The opposite of 5 is negative 5. The x values do not change. However, the y values become the opposite. Now consider the function h of x equals f of x negative 1. Think about that. So we are thinking about this. I have to plug in, everywhere I see an x, I have to plug in a negative x. Let's use I have to plug in the negative x. So, negative x squared minus 6 times negative x plus 5. Okay, this is the interesting part. What's a negative number squared? Positive. So this just becomes x squared. What's a negative number times a negative number? A positive number. There's nothing happening here with x's, so it's just plus 5. So this is what h of x is going to be. How is the graph transformed to produce the graph of h of x? Well, we're going to see that, it's a reflection across the y-axis. So let's go back up here and graph it. First of all, I'm going to label the blue one as g of x, which equals negative f of x. Now let's do the green one, and it is a reflection across the y-axis. So, since we can type the equation into the calculator, or we can take this point, count the distance to the y-axis, 1, and then go that far again. Reflection across the y-axis. This point, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This point, make sure you use the original function. 1, 2, 3. 1, 2, 3. That point is right on the y-axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Label it. I believe it was h of x equals f of negative x. How is the graph transformed? Reflected across the y-axis. And there is a summary, and you know the summaries are always in rectangles. Okay. Exercise number 2. Determine an equation for the linear function g of x equals 5x minus 7 for both after reflection in the x-axis and y-axis. Label your equations. So we have the x-axis reflect and the y-axis reflect. The x-axis reflect, remember that was for lack of a better letter, k of x equals negative g of x, negative parenthesis 5x minus 7, distribute the negative sign, negative 5x plus 7. Y-axis reflect, j of x equals g of negative x, which is 5 times negative x minus 7, which is just negative 5x minus 7. Okay, that finishes it for the first page. Let's take a look at the second page. With exercise number 3, what's going through my mind? Well, if a parabola has the equation f of x, which of the following equations represents a reflection in the x-axis? So what's going through my mind is I have a point, and it goes down to there. Well, what happened? The x value stayed the same, the y value changed. So that means if the y value became its negative, that means that the reflection is negative f of x. So put that in parentheses. And now I distribute the negative sign. So it's negative 2x squared, get rid of that answer and that answer, plus 3x, still the same answers, minus 8, choice number 2. After reflection in the y-axis, the quadratic function g of x, what happens to it? Well, a reflection across the y-axis only affects odd exponents. That's the reflection on the y-axis. It only affects odd exponents. And as we saw on the previous page, here, a negative number squared is a positive number. So it's positive 4x squared. Those two are wrong. Negative times a negative is a positive, so it's plus 7x. Good. But there's nothing happening to the plus 2, so it stays the positive 2. Consider the function g of x equals negative x squared plus 4. What two transformations have occurred to the graph y equals x squared to get to g of x equals negative x squared plus 4? Be specific. Make sure you write the transformations in the order in which they occur. Well, the first thing that I notice is that the turning point is going to be positive 4. It's going to be a negative, and that's at positive 4. So if I say that we shifted up 4 and then reflect across the y-axis, if I shifted up 4, then reflected across the y-axis, it's then going to look like that. No, the turning point is not there. We know for a fact that the turning point is there because it says plus 4. So we cannot reflect it first. I mean, we cannot shift it first. We have to reflect. Reflect across x-axis, then shift up 4. Exercise 6. The graph of the function f of x shown below on the two grids. Sketch the graph of the reflection across the y-axis and the reflection across the x-axis. So we're going to do a reflection across the y-axis right here. We go down to 6 and go down 6. These 2 points here are just one closer to the y-axis, to the left and to the right. That one is now down 2, it's up 2, so I go down 2. This one is up 2, so I go down 2. And this point, 1, 2, 3, so you got to go up 1, 2, 3. Same thing for the other side. That's the beautiful thing about parabolas. Now, I can sketch it. Do the bowl. Reflected across the y-axis. The point on the y-axis stays on the y-axis. The point 1 on the left goes to 1 on the right. The point 2 on the left goes 2 to the right. The point 4 goes 4. The point 1 to the right goes 1 to the left. There we go. So this is, it says label it, negative f of x. It says label it, f of negative x. Great. That's it for reflection across the x-axis and y-axis. If you have any questions, make sure you ask me in class. Your homework is obviously the next 2 pages. Catch you later, guys and girls. Bye.